This is problem 5.35 from AOPS Introduction to Number Theory. M and n are positive integers such that the GCD of m and n has 5 divisors, and the LCM of m and n has 30 divisors. So what is the greatest possible number of prime divisors that n could have? So for m and n right now, the most important clue is the GCD, because the GCD is our minimum. So despite the fact that we want n to have the greatest possible number of prime divisors, we need to have a minimum first. So we know that GCD mn is equal to 5. What does this mean? This basically means that GCD m and n has 5 divisors. So what does this mean? This basically means if I took the least exponent, so m is equal to, let's say, so m is equal to p1, e1, p2, e2, etc. to pn, ptm, etm, where tm is the number of divisors for m, and n is equal to p1, f1, p2, f2, all the way to ptn, the number of divisors of n, etn. So let's say this is m and n, and we have GCD m and n. So GCD m and n is going to be equal to p1 to the power of the minimum of e1 and f1, the minimum of e2 and f2, etc. So etc. all the way to the minimum of the last exponent. So yeah. So this is our GCD. So if the GCD has 5 divisors, then the minimum exponents between m and n for every prime here multiplies up to 5. So let's just say the minimum is m. The minimum, so we want n to have the greatest number of possible divisors. So how about we let m be all the minimums. So therefore the minimum value here will be the product of the exponents of m plus 1, which is equal to 5. So there's only one possibility, which is where the exponent of m is 4. So m is going to be equal to p to the power of 4. So now we want n to be the largest possible, to have the largest possible number of divisors. We know that the LCM is equal to 30, or the LCM has 30 divisors. So what this means is that if we took the largest exponent from every number, so we took the largest exponent from every single prime in m and n, and we multiply those together to form a number, that number has 30 divisors. So 30 can be factored as 30, 2 times 15, 3 times 10, etc. However, right now, what we want is So right now what we want is to let n have the largest number of possible prime factors. So the largest number of factors that we can write 30 into is gonna be 2 times 3 times 5, because that's literally the prime factorization of 30 expanded. So the largest number of factors that I can have is 3, so we have p1 to the power of 2, or no, p1 to the power of 1, p2 to the power of 2, p3 to the power of 4. So this is the best way which we can express m and n for their GCD and LCM to be 5 and have 5 and 30 divisors. So our answer here is going to be 3. So the key in this problem here is to realize that the GCD defines the minimum value. So we want n to be the maximum value. So we let m be the minimum value. And the LCM basically is the upper bound. So we let n literally fit the upper bound. So that it's the largest number of prime divisors that n could have. So thanks for watching.